And here we are again. So this is going to be a video to go through the entire paper this time, as requested. Uh, it shouldn't take me 2 hours though, I hope, but I'll go through and hopefully it'll just take as long as it normally takes. So 22 questions, here we go. The diagram shows a shape, PQRS All the corners are right angles, the lengths of the four sides are given in terms of A and B. An expression of A and B for a PU. So we're looking from this distance to here. Well, I know that it's going to be that distance plus that distance because they are right angles, therefore it's a rectangle, so they're parallel. So it's going to be B plus 3A, B plus 3A. PQ is going to be 3A plus 2B, that's the bottom length here, minus that bit there, minus A minus B. So that's 3A plus 2B minus A plus B, because you've got the minus times the minus. 3A minus A is 2A plus 2B plus B is 3B. 2A plus 3B. 2A plus 3B. Question number 2. Philip and Nikos share some money in the ratio of 3 to 4. Nikos receives £24. Okay, so 3 lots of something go into 24. So 3 times something equals 24. And that something equals 8. So for every 3 lots of 8 that Philip gets, Nikos gets 4 lots of 8. So it's going to be 4 times 8, which is 32. So I'm going through this one quite quickly, just to save a bit of time. James and Suki share £40 in the ratio of 3 to 5. How much do they get? Okay, so 3 plus 5 equals 8. 40 divided by 8 equals 5. 3 times 5 equals 15. 5 times 5 equals 25. And that should give us the correct amount. Suki is this one, because it's the first is that one and the second is that one. So she gets £25. And just to double check, 25 plus 15 equals 40. We're good. 3. Diagram showed a wall. Calculate the area of the wall. Okay, and cut it into 2 parts, one rectangle and one triangle. The rectangle is 2 times 1.5, which is 3. And the triangle is 1.5 times 1.2 divided by 2. It's the area of a triangle, base times height divided by 2, which is going to be, get my calculator out, 1.5 times 1.2 over 2 is 9 over 10, or 0.9. The area of the wall is going to be those two added together. 3 plus 0.9 equals 3.9. 3.9. 1 litre of paint covers an area of 20 meters. Work out the volume of paint needed to cover the wall. Okay. Well, it's going to be 3.9 divided by 20, which is 3.9 divided by 20 is 0.195. And in milliliters, that's 195 milliliters, because there's 1,000 milliliters in 1 liter. So 195. 4. A train travels at 165. Average speed is this. Okay, so speed equals distance over time. Therefore, time equals distance over speed. And time is 165. 165 over 60, which is 2.75. 2.75 hours. It says give you an answer in hours and minutes though. So it's 2 hours and it's not 75 minutes. 75, it's 0.75 of an hour. So 0.75 times 60 is 45 minutes. That's 3/4 of an hour. When Peter goes to work, he can be early or on time or late. The probability that he is early is 0.1. The probability that he is late is 0.1. What's the probability he'll be on time? Okay, well, I know that 0.2 plus 0.1 plus something equals 1. 1 represents 100%. Okay, so you can only be that or that or that. You can either be early or late or on time. Yeah, that's right. So I know that that must be 0.7. So 0.7. Peter will go to work 20 times next month. Work out an estimate for the number of times he'll be early. Okay, so he's early 0.2 of the time, 20% of the time. So 0.2 times 20 equals 4. Okay. Question number 6, multiply out this. Well, that's going to write it straight. 5x minus 10. X over 4 plus 3 equals 10. It says solve this. Okay, so what I'm going to do first equals 10. So I'm going to times by 4. No, I'm not going to do that first. I'm going to minus 3 first. Peel that onion. Minus 3, x over 4 equals 10 minus 3, which is 7. I'm going to times by 4 both sides. I get x equals 28. Okay, then solve the inequality. 5x minus 6 is greater than 2. I'm going to plus 6 to both sides. We get 5x is greater than 8. And divide by 5. Divide by 5. X is greater than 8 over 5. I'm just going to check just to make sure I am correct on that one. So if I put 8 over 5 is 1.6, so I'm going to try 1.7. So 5 times 1.7 minus 6 is 2.5, which is greater than 2. So my answer should be, I hope, correct. Next one. Right, we've got Pythagoras here. I know that 4 squared plus 6 squared equals h squared. So 2, 3, oh no, it's going to be 16 plus 36 equals h squared. So that's 52 equals h squared. So the square root both sides, and the square root of 52 is 7.21. So h equals 7.2111, and to 3 significant figures, that is 7.21. John goes on a trip. Here's a graph. Here's a travel graph for his trip. Distance away from home, time. Okay, so he's moving forwards in a steady straight. Okay, so we've got 4 statements. John is not moving. Okay, part A. He's got John is not moving, traveling at steady speed. His speed is increasing, i.e., accelerating. And this one is decelerating. So part A, I can see that he's going at a steady rate away from home. Home is here, and he's just going at a steady speed there. So that's John. I'm just going to write steady speed. Part B, I can see that time increases, but his distance from home doesn't increase. So that means he's not moving. And part C, a lot of people would write he's decelerating because it kind of looks like he's decelerating, but actually he's accelerating, because if you look at the beginning here, it takes a long time to move a little bit of distance from here back towards going home. But as time increases, his speed increases as well. So here, from let's say from here to here, yeah, he's traveled that far. But in the same amount of time up here, I can see that he only travels that far, not very far at all. So he's actually increasing speed. Okay. Question 9, sets, no problem. Positive integers is less than 11, so that's 1 to 10. A is all multiples of 3, and B is all multiples of 2. So A, list the members. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Don't give much room for that. A union B, so it's in A or in B, so we're looking for all positive integers less than 11 that are also multiples of so they're multiples of 3 or positive integers less than 11. Okay, well, that's the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's the same, because remember that union there means in A or B. Okay, and anything that's in there or anything that's in there. Okay. The universal set is students in class 12Y. P is students who study maths. Q is students who study history. Describe the members of P intersect Q. So that's students in 12Y who study maths and history. R is also a set of students in class 12Y. P intersect R is the empty set. So that means no students studying maths are a member of the set R. Express 132 as a product of its prime factors. Ugh. 132 is 2 times 66. 66 is 2 times 33. 33 is 3 times 11. And that's a prime number, that's a prime number, that's a prime number, and that's a prime number. So if I do 2 times 2 times 3 times 11, that will give me the answer that I want. We have to express it in index form, usually 2 squared times 3 times 11. Product just means multiple. Prime is a prime number. It's got no factors other than itself and 1. And a factor is something that multiplies in. So factors of 132 are 66, 33, 2, 2, 3, 11, and any combination of these as well. So, yeah, that's our answer. 11, a coin is biased. Oh dear. When it is thrown, the probability that shows heads is 2/3. He throws the coin twice, complete the probability tridiagram. Okay, so it either has heads or tails, so this one here must be 1/3 because 2/3 plus something must equal 1, as I said earlier on. The second throw is exactly the same because the probability doesn't change. Heads, tails. You've got to write in these words as well, otherwise we don't know what probability we're talking about. Find the probability that find the probability that the coin shows heads both times. Okay, so the only way that that happens is for this happen and then this happen, and that's going to be 2 over 3 times 2 over 3. If it's the probability of something happening and something else happening, we always times. If it's or, we add them. Okay, so that's going to be 4 over 9. Find the probability that the coin shows heads at least once. Okay, so this route is okay. This route is also okay because he's shown heads once and then a tails, and then this route here is okay. This route is not okay because there's no heads. So we've got 4 over 9, which is the first one, plus now, because it can be or, 2 over 3 times 1 over 3, or 1 over 3 times 2 over 3. And that's going to be 4 over 9 plus, oops, 2 over 9 plus another 2 over 9. So that's 8 over 9. Another way to work that one out, which actually is a more elegant way, is that I can see that there's only one way that doesn't work. So because there's one way that doesn't work, I can say, well, what's the probability of tails and tails? It's 1 over 3 times 1 over 3, which is 1 over 9. And I know that the other 3 ways of doing it together will provide the rest of the fraction up to 1. So like I said up here, it's going to be 1 over 9 plus the probability of all of the other 3, those 3 up there, equals 1. So it must equal 8 over 9. 8 over 9. Okay, 1 over 3 plus x equals 1. Nice. Next question. A, B, and C are positive numbers, so greater than 0, such that A times B is greater than or equal to 1 and less than 10, and C is greater than or equal to 1 and less than 10. Right? So here we've got write down the value of M. Okay. Well, I would say that then A times 10 to the 4 times B times 10 to the 7, oh, I see, equals C times 10 to the M. Now, I know that I can just say that C equals AB. I know that because C is between 1 and 10. It's less than 10. So it can't affect my numbers here. Okay. C equals AB. And so you're going to get AB times 10 to the 4 times 10 to the 7, which is AB times 10 to the 11. So that there must be 11. Oh, there you go. I've already done it. Find an expression for C in terms of A and B. C equals AB. N, big N, equals 3.2 times 10 to the P times 4.5 times 10 to the Q, where P and Q are integers. Express N in terms of P and Q. Give your answer in standard form. Okay, well, it's going to be 3.2 times 4.5 times 10 to the P times 10 to the Q. 3.2 times 4.5 is 14.4, and that's going to be times 10 to the 9 plus 8, which is 17. But it also says we need it in standard form. Standard form, this number here must be between 1 and greater or equal to than 1 or less than 10. Okay, for it to be standard form. And at the moment, this is 14. So I need to be 1.44. Yeah, if I did 1.44 times 10, that would be 14.4. And then I still have a times 10 to the power of 17 here as well. But of course, now I can combine those, 1.44 times 10 to the 18. So that's my answer. Hang on, why have I got 18? Nope, I'm completely wrong. My apologies, because that's not going to be 17. I misread that. It's P and Q, so times 10 to the P plus Q. 10 to the P plus Q, so it's going to be 10 to P plus Q plus 1. So 1.44 times 10 to the P plus Q plus 1. Next question, solve. Should be able to do this one. We did this in class. This is a quadratic, so I'm going to use the quadratic formula because it's the easiest way of doing it. A equals 1, B equals 2, C equals -1. So negative b plus or minus the square root of b squared minus 4ac all over 2a. That equals -2 plus or minus the square root of b squared, which is 4, minus 4 times a times c. So 4 times a is 1, times -1 is -4, but we've got a negative there as well, so it's going to be plus 4 all over 2a, which is 2. So that equals -2 plus or minus the square root of 8 over 2, which is -2 plus or minus 2 root 2 over 2, which is -1 plus or minus the square root of 2. Okay, to give my answer to 3 significant figures, well, this is going to be, is that right? Yeah, I think so. I'm going to actually use my calculator just very quickly just to check my answer, because again, just because I can. Polynomial 2, 1, 2, -1, 1 plus root 2, 1 minus root 2. Okay, yep, that's right. So 1 plus root 2 on my calculator is 2.41, the 3 significant figures, and the other one, like 1 minus root 2, is going to be negative 0.41. Oh, that's a nice question. 414. Now, the reason I'm doing that is that this is 3 significant figures because 2 is the first significant figure, so 1, 2, 3. But on this one here, the first 3 significant figures, the first significant figure is that one there. So we look at those 3 there. So we've got 2 answers with different numbers of decimal places. Right, next question, solve this. Okay, 2 over y plus 4 equals 3. I'm guessing that you'd be able to work this out in your head just by trial and error, but we're going to do it the proper way. We're going to times by y plus 4, both sides, and we're going to get 2 equals, 3 times y plus 4. We're going to divide by 3, and then we're going to minus 4. 2 over 3 minus 4 equals y. Oh, maybe I couldn't work that out in my head at all. 2 over 3 minus 4, 2 over 3 minus 4 is negative 10 over 3. Y equals negative 10 over 3. Negative 10 over 3. I'm just going to check my answer. So I'm going to put in 2 over x plus 4 equals 3. Perfect. Question 14. Looks like a bit of trigonometry to me. SOHCAHTOA, silly old hens can't always have tons of acorns. Can't always have. So I'm going to use cosine. Cosine of 32 equals 6 over h. So h equals 6 over cosine 32, and just multiply both sides by h, and then divide both sides by cosine 32. And then get my calculator. 6 over cosine 32, 32, yep. Six over cosine 32, okay, yep, equals 7.075, and to three significant figures, that's 7.08 centimeters. Next one, all right, this is the area of a triangle. Now, here, what we've got is something quite different. I'm going to use a different formula that we haven't seen before, but I'll just introduce you to it. It's nice, straightforward, really. It's just plugging in numbers. So the area of a triangle is half of A times B. So if I've got half of A and B, and then times by this half of A times B times sine of this angle here, I get the area of the triangle. All right, so I'm looking for two lines, two sides, with an angle in between them. Where were we? Oof, even more fun. Because, well, I've got two sides, but I don't have the angle between. However, I can work that out because that angle there is going to be 180 minus 40 minus 25, one mark right there, which is 180 minus 40 minus 25, 115. And now I can use that that formula. Okay, so area equals half AB sine C, which is half times 3 times 7 times sine of 115, which goes straight into the calculator. Half times 3 times 7 times sine of 115 is 9.516. Three significant figures is 9.52. 9.52. Okay. Solve the simultaneous equations. Right, now this we haven't done, but it's doable. What are we going to do? Okay, I'm going to use, it doesn't say if I use elimination or substitution, so I'm going to use substitution because I like it. I'm going to choose this equation here, and it says x minus 2y equals 2. So I'm going to get x equals 2 plus 2y. Okay, so now I have x in terms of y, and I'm just going to substitute that x into there. Simultaneous equations means that you want to find a solution, an x and a y, that works for both equations at the same time. So the x in here will equal the x in there, which is why I can substitute. So here I got 5x plus 4y equals 3. I'm going to substitute 2 plus 2y as that x right there. So I get 5 times 2 plus 2y plus 4y equals 3. Now I can actually solve this quite straightforwardly. 5 times 2 is 10. 5 times 2y is 10y plus 4y equals 3. So now I can start working this out as well. That's 14y, and minus 10 from both sides equals negative 7. So y divided by 14, negative 7 divided by 14 is negative half. Okay? And then I can just use that number in, well, any of my other equations. Let's put it in this equation here because it's easier. X minus 2y equals 2. Well, we know y equals negative a half. So x minus 2 times negative a half equals 2. X plus 1 equals 2. Therefore, x equals 1. Okay? So x equals 1. and y equals negative a half. The histogram shows information about the masses in grams of some stones. Okay, there are 120 stones with masses of less than 30 grams. So if I just have a quick count, 1, 2, 3, 4, 5, 6. Okay, that means that each of these blocks is worth 120 divided by 6. So that's going to be 20, 20, 20, 20, 20, 20, 20. Okay. Estimate a number of stones with masses between 35 and 70. Okay, well, it's going to be half of that plus that plus those two. So I'm going to have 20 plus 20 plus 20 plus 20. Those two together make 20, those two make 20, and those two make 20. So 2, 4, 6, 8, 10, 12, 14. Oh, no. Oh, sorry. It's a histogram. My bad. My silly. There are 120 stones with masses less than 30 grams. Oh no, it's still okay. So no, it's right. So what did I say before? 2, 4, 6, 8, 10, 12, 14. So 140 stones. Yeah. Okay, factorize this. That means put it into two different brackets. So I know they're going to have 2x plus or minus something times x plus or minus something. And it's going to be a 1 or a 3. Okay. How do I know all this? Because 2x times x is going to give me my 2x squared. And then my last number there comes from these two being multiplied together. So does the 3 go here, or does the 3 go here and the 1 go here, or the 1 go here and the 3 go here? Well, the easiest way to do it is just try a bit of trial and error. I can see pretty quickly that I'm going to get 3 and a 1, because if I have 2x plus times 1, I'm going to get 2x plus, and then the inner ones are going to be times 3 times x, which is 3x, so I'm going to get my 5x. So my answer is 2x plus 3 times x plus 1. Factorize 4y squared minus 9. Okay, so that's going to be 2y plus 3 and 2y minus 3. This one here, if there's no non-squared letter, then it means that the second part of your fraction must always be the same thing, but just in reverse. So one's positive and one's negative. Look at what they multiply to. It's going to be negative 9, so that's 3 and 3. So that's going to be my answer. 2y. How do I know it's 2y? Because I know 2y times 2y is 4y squared. It's 2y plus 3 and 2y minus 3. Find the value of 9 to the half power to the fourth power. Well, that's going to be 9 to the 4 times a half. This is something that we can, it's a rule that we can use, it's called an index law. That's going to be 9, 4 times a half is 2, which is 81. Or, I mean, you can just put it in your calculator. Express 5 to the 20 as a power of 25. Okay, so what it's saying is 25 to the what power equals 5 to the 20. Well, I know that 5 squared equals 25. Okay, so 5 squared to the power of 10 is the same as 5 to the 20 power. So I know that it's going to be 25 to the power of 10. 25 to the power of 10. Express root 8 as a power of 2. Well, root 8 equals root 4 times root 2, which is 2 root 2. The diagram shows a trapezium ABCD. BC equals 2AD. Oh, okay, write that in. Okay, 2AD. And AB equals X, AD equals Y. Okay. Find in terms of X and Y, AC. All right, so BC, it says it's 2AD. AD is Y, so this must be 2Y. So AC, all I need to do is go this way and then this way, okay? Which is X plus 2Y. That's it. It's just counting and reading. DC is going from there. Oh, it's going from there to there, but we can't quite do that, can we? So what we can do is we can go that way, then that way, then that way. So what's this way, that first stretch? Well, that's actually, because y is going that direction, we want to go the other direction, so we want negative y plus x plus 2y, which is x plus y. Okay, x plus y. The point E is such that AE equals x plus y. I missed something out. Okay. Use your answer to part A2 to explain why AECD. Oh, AE, I see. So I was looking at DC. AE equals x plus y. Well, AE equals x plus y, so E is going to be there. And I know it's a parallelogram because AE, oops, AE equals x plus y, therefore is parallel to DC. Okay, so that line there is parallel to that line there. And I know that therefore and EC is parallel to AD. Yep. Differentiate with respect to x, right? This is something where you can pick up some really easy marks, actually. You get the x, right? You take that number, you move it down by one value, and then you times that number by the original number. So I've got 3x squared minus x. What you do is you write dy by dx, and like I said, I do 3 times 2 times x to the 2 minus 1. Okay? So where does that 2 come from? That 2 comes from the original 2 there. The 3 is from the original there, and here we just reduce the number by 1. Sorry, the index by 1. So 2 minus 1. Minus, well, here we've got x to the 0, because it's x to the 1 minus 1 is 0, times by 1. So it's just going to be 1. So x differentiates to 1, minus x differentiates to negative 1, something that you can remember as well. So dy by dx equals 6x to the power of 1, which is 2 minus 1, minus 1. 6x minus 1. 1 over x, x is the same as what x to the negative 1. So dy dx is negative 1 times x to the negative 1 minus 1, which is negative 1 x to the negative 2, which is negative x to the negative 2. Or, if you really want to be fancy, it's negative 1 over x squared. Find the coordinates of the points on the curve y equals x cubed, where the gradient is 12. That's an easy one, but I'll do it anyway. Now I know that y equals x cubed. I can differentiate that. dy by dx, sorry, that's dy over dx is 3x squared. Use the same thing, that goes down by 1, and we multiply it by the original index. And I know that this actually here tells me what the gradient of the curve is at any point. So I know that the gradient dy by dx is 12, and that equals 3x squared. And then this is just a thing. This is just an equation for finding out what x is where the gradient is 12. So divide by 3, and I get 4 equals x squared. Oh, lovely. So x equals plus or minus 2, square root of 4. Now, if x equals 2, y equals 2 to the power of 3, which is 2, 4, 8. And if x equals negative 2, y equals negative 2 to the power of 3, which is negative 8. So we get 2, 8, and 2, negative 8. Two more. The function f is defined as f of x equals 1 over x plus 3. Find the value of f of 2. Well, all you do is you put that 2 in there. That's all you do. 1 over 2 plus 3 equals 1 over 5. One easy mark. State the value of x which must be excluded for the domain of f. That just means what value of x doesn't work for this equation. Well, as you know, you can't have 0 in the denominator. So x plus 3 equals 0. If that's true, then it screws everything up. So we cannot have it. It must be excluded. The domain is all the numbers that you can use and put into this formula right here. So x equals negative 3. Okay. Given that f of a equals 1 over 10, well, x plus 3 equals 10, because I'm just looking at that and the same as that. So x equals 7. Yeah, so a must be 7. The function g is defined as this. We express the function gf in the form gf of x. Okay, so I'm just going to go through this one. Essentially what you do is you put f of x into g of x, and f of x is 1 over x plus 3. So it's g of 1 over x plus 3, is that right? Yeah. So that goes into here. So we're going to get 1 over x plus 3 plus 2. And it says, give your answer as a single algebraic fraction. So this at the moment is not a single algebraic fraction. So we need to rearrange it just a little bit as well. Rearrange it to 1 plus 2 times x plus 3 over x plus 3, which is 1 plus 2x plus 6 over x plus 3, which is 1 plus 7 plus 2x over x plus 3. That's my answer. Last but not least, question 22. ABC is an isosceles triangle. AB equals AC equals 1. M is the midpoint. Okay. Use trigonometry to find an expression in terms of x for BM. BM. Okay. Well, BM there is going to be our sine, because I know that's a right angle there as well. So I'm going to use silly old hens, that's being my opposite, that being my hypotenuse. So I know sine x equals opposite over 1. which is, well, sine x equals 1. BC, well, that's sine x, and that's the same, so it's 2 sine x. 2 sine, oh, hang on. Oh, hang on. Use trigonometry to find an expression in terms of x for BM. Oh, sorry, no, I've done that wrong, just a tiny little bit there. Not equal to 1, that's equal to BM, that length there. So BC, yeah, BC equals 2BM, so it's 2 sine x. Use the cosine rule to find an expression in terms of cosine of 2x for BC squared. Okay, so that's that thing there. So the cosine rule is a squared equals b squared plus c squared minus 2bc cosine of a, where this is in the front of the paper in the formula booklet, where you've got any triangle and you've got a over here, and that's a, the one opposite, and then you've got a b and a c. So this is what we've got here. So a, our angle A is going to be 2x, our B is 1, our C is 1, and our A here is 2 sine x. So, actually, so A squared, so 2 sine x squared equals 1 squared, which is 1, plus 1 squared, which is 1, minus 2 times 1 times 1, which is 2, cosine of A, cosine of 2x. Okay, so yeah, so that's in terms of cosine x. Use the cosine rule to find an expression in terms of cosine x for BC squared. Okay, so BC squared equals 2 minus 2 cosine 2x. Okay, hence show that cosine x equals cosine 2x equals 1 minus sine x squared. Okay, well, 2 sine x squared equals 2 minus 2 cosine 2x, which is 4 sine squared x equals 2 minus 2 cosine 2x. Divide everything by 2 and we get 2 sine squared x equals 1 minus cosine 2x. Almost there. And rearrange that just a little bit, and we get cosine 2x equals 1 minus 2 sine squared x. Sine squared x is just sine x squared. Oh, done. Finished. I think it's all right. Might be. Probably. Potentially. Possibly. Anyway, I hope you've enjoyed that. Even if you didn't get so far through, it's still good practice just to go through some of the more difficult questions as well. Don't worry if you didn't follow some of the harder stuff, but some of the easier stuff, I think, like certainly the first 10 questions, and there were a few of other questions that you all should be able to pick up along the way. So yeah, have fun with that, guys. Cheers.